and why would you choose one versus another? Now, another interesting area is the topologies of informing systems. Here, once again, our field has evolved in quite a bit since the early papers. Now, in the early view of informing system, we sort of based the notion on Shannon's model. So you have an informer, and you have some sort of channel transmission medium, and then you have some sort of client. And essentially, we tended to view the processes in that way. And for many information systems, that's an appropriate way to view the flow of information. However, for many real-world informing settings, that doesn't work nearly as well. Bill Murphy, who's a doctoral student of mine, recently had a paper published in Informing Science where he sort of charted out the Informing Science Institute as an informing system. And if you take a look at the Informing Science Institute, well, first off, it uses many, many channels. We have got our conferences, as we've got now. We've got the various journals. We've got the books in the Informing Science Press. We have outreach, where we write articles about informing science that get published in other disciplines. Our clients come from many nations, many disciplines, but what's particularly important is our clients are the folks who are writing these things, so they're also the informers. In a recent book on the case method, I tried to chart out an example of a university topology, and here what I was interested in was not only the flow of informing, for example, and I won't go into detail because as you describe real-world systems, it starts to look like a plate of spaghetti and about as easy to explain. But essentially, what you have is informing flows, which are the sort of bigger arrows, but you also have resource flows, which are the solid arrows. The resource flows are the hollow arrows, the informing flows are the solid arrows, and you've got basically imperfect measurements of these flows that throttle your resources. And, basically, this looks like a submarine piping diagram, and that's not coincidental because that's how I describe systems like that. But the point is there are many, many different topologies, and we really haven't studied how the impact, for example, of the harmony of resource flows to informing flows affects the behavior and growth of systems. These are very interesting, and they're very important not only for technology systems, where you're building systems that are likely to be fairly inflexible once they're fully operational, but also in developing organizational informing systems. Then we move into social network topologies. This is just a section of a judicial social network written by Katz and Stafford in a 2010 paper. I just wanted an example. All of the people in yellow are Supreme Court justices in the US, and then you have circuit court judges and other lawyers, and basically what they were trying to do was determine the connectivity of legal opinions between these things to determine, who were the centers of these clusters. Now, quite honestly, I don't know what the implications of this are, but I feel a little guilty about that because this is obviously a very important informing system, and this is an area we ought to be thinking about. So, what are some of the interesting issues? Well, of course, what type of settings are most appropriate for different topologies? To what degree is the effectiveness of our informing a function of the topologies that we create? Another one that's of interest in light of things like the recent collapse of financial systems and stock markets and so forth is what type of topologies are particularly prone to phenomena like information cascades and fads, where the behavior of one individual informs a whole bunch of other individuals and they all start behaving in the same way, thereby producing major changes to systems that appear to start from very small initial stimuli. Another important area of informing science has been the obstacles to informing. I some of the key terms that we sometimes use is bias. The fact that what the information that we receive does not necessarily lead to the same patterns that among everyone, because each person has his or her own bias. A misinforming system is a system that usually accidentally produces the wrong type of information amongst its various clients. Then you have disinforming systems that are specifically designed to produce misinformation among clients. So, the basic model, and this is, I pulled this from Eli Cohen's paper, I think it was in 2009, I think, where basically you have bias on the part of the informer, which leads to a certain impact on the informing process, plus bias on the client, and between these two, you get a very different pattern than might reflect the reality. Here is an example of another bias model. This actually originated from Hyland and Jameson, and this is a sort of revised version that I published. And, it describes some of the challenges that we face when we inform. So first, we've got to get people's attention. So, the little clouds show some of the typical reactions. Well, if someone's trying to tell you a theory and it's too complicated, what's the easiest thing to do? Well, go to sleep. I see I've been very effective with some of you. Another thing is you hear a part of a pattern that's familiar and you say, oh, I've heard this before, and thereafter everything you hear is exactly what you thought you were going to hear, whether or not that's actually what was conveyed. Another is the cognitive bias. Well, this is not credible because I have had a different experience than what is being described. The motivation bias. Well, this is all well and good, but this problem is nothing like the ones that I deal with. And then finally, there's the visceral bias. Well, I don't trust someone who is so different from me. These are all examples of things that information has to go through before it can make changes to the client's sort of semantic models, the meaning the client experiences. These things are very important. There's a particular challenge of informing experts. One of the great fallacies of business research in general is the notion that we're going to go out and inform experts as a result of our hypothesis testing. Well, I have never heard such a ludicrous idea in my life, because it's very hard to inform an expert, because, especially when you're dealing with a hypothesis, because a hypothesis, there is a good chance the expert is going to have some experience that suggests that hypothesis to be false. No informing will take place at that point. They will simply ignore you. On the other hand, there's a distinct possibility that a hypothesis that we're testing, the expert already believes to be true. Well, no informing takes place at that point. Consider the technology acceptance model in MIS, a personal favorite of many of us, which the core concept of the technology acceptance model is that if a system is useful, we are going to be more motivated to use it. 400 articles have studied this grating problem with the notion of telling experts, yes, well, by the way, if the system's more useful, chances are you're going to want to use it more. Holy mackerel. Well, we're down there in that, there's no informing. If you want to inform an expert, you got to find that tiny zone in the middle where the expert really doesn't know. Then you've got a chance, but that's a very small zone, and the more expert the person views himself or herself, the smaller that zone is going to be. That is one of the reasons why it's so hard to inform academics, because we believe ourselves to be experts in everything. Now, a particular favorite area of mine, which has been the subject of a lot of recent informing science articles, has been the issue of informing in complexity. My personal belief is that if you understand the complexity of the informing that needs to take place, you will have a much better chance of understanding the type of systems that are going to be most effective in doing that informing. There are basically three major classes of complexity. There is complexity that deals with lack of structure. Essentially, the problem's unfamiliar. There's complexity dealing with the size of the problem set. In computer terms, like the number of lines of codes, the number of paths through the code. We'll call that complicated. And then finally, we've got objective complexity, which is the type of complexity which hasn't really been studied that much in our field, but has been studied a lot in the field of biology, where it's a principal model for evolutionary systems. And this involves whether or not a problem can be broken up into smaller parts and smaller effects. In a decomposable world, and by the way, anytime we do hypothesis testing of simple hypotheses, we look like that stack on the left, where we have a series of variables, and each variable impacts a certain amount on fitness, and that impact can be separated. Well, in a complex world, essentially the variables all interact, so you cannot separate out the impact of individual variables, and a small change in one variable can lead to a huge change in outcomes. A good way of looking at a decomposable system is the way we rank colleges or papers or universities. We like to come up with a formula, a rubric. Okay, you get so many points for publishing in this journal. You get so many points per paper. We add them all together, and that's your research productivity. A better way of looking at the decomposable world is a cookbook. If I were to ask you, for example, what percentage of the fitness of this cake was a result of the flour you used, what would the answer be? I don't know. How about baking soda, baking powder? It doesn't really have much of a taste. You only use a teaspoon of it. What happens when you leave baking powder out of the cake recipe? You bake a brick. So, what percentage of the fitness is a result of baking powder? Now, one of the most ridiculous exercises that I have ever been required to do involved when I went up for promotion, and I was asked to rank my percentage of the contribution to each article where I was a co-author. Now, by the way, if you ever, for those